talk today is about large language models, vector embeddings, and vector databases, how they put them all together. Right, by the way, my name is Anton Umnikov. I'm a principal solution architect in Redis. Right, we have a fancy title that includes Hello World. And for me, Hello World today is the foundational paper that started the generative AI revolution as we know it today. Right? Hello World of Transformers. I usually, every conference I go to, I count the number of times this paper being mentioned in all the sessions. Right? I'm surprised I haven't seen mention of this paper in any of the keynotes today. But attention is all you need. Foundational paper published in late 2017 that talks about transformer architecture. That essentially introduced the architecture of transformers. Quick show of hands, who've seen at least the name of that paper, maybe one of the pictures on the screen? Yeah, like pretty much everything. Now, show of hands who actually read the paper. Okay, few people actually read the paper. For those who didn't, paper introduced architecture of transformers, actually two of them, encoder transformer and decoder transformer. Right, and author of the paper used both of these transformers together to solve the task of machine translation from one language to another. They started with English to German translation, then they did the same exercise for English to French. They set the record in terms of accuracy on what is called a blue score. And blue score is used to evaluate the quality of machine translation or even human translation, where 0 being total garbage, like, and 100 is a perfect translation, frankly unattainable even for the best human interpreters, human translators. Right? More importantly, the transformer architecture not only set the record in terms of quality of translation, it happened to be very powerful, very economical architecture to implement and train. This architecture is very parallelizable, so it's easy and fast to train these transformers in order to achieve the task that you need. Again, if you look a little bit deeper, there are two types of transformers: encoder transformer on your left that essentially extracts the semantic meaning of that text, and turns into vectors. Right? Then these vectors are being fed into the decoder transformer, right? That one by one translate the semantic meaning into the output text, right? So, but interesting thing happened right after the paper was published, right? That's late 2017. People started to use these transformers independently. Right, so encoder transformer, right? And encoder transformer is being trained to understand the entire semantic meaning of the body of text that you translate in. So essentially the way it's trained is they mask random word within the sentence or paragraph, right, and let machine predict that word. So it has attention both left and right to the text, right? And right away, this architecture was picked up by a lot of researchers, and the architecture called BERT emerged, which happened to be like best thing since sliced bread in machine learning, in natural language processing in 2018 up to middle 2021. Right? The decoder architecture, right? Decoder architecture predicts the last word, the next word in the sequence. So attention here is only to the left, right? And it does predict one word at a time, and then the whole thing is being fed back to the transformer to predict the next one, right? In the original paper, it takes the vector embedding that embeds semantic meaning of the text, and then you add word by word and you generate the translation. Then someone really smart thought, do we really need this vector embedding in front? Can we just feed this thing beginning of our translation or whatever it is and let it complete it? And guess what happened? This is beginning of GPT architecture. So ChatGPT as we know it, Llama 2 as we know it, is essentially decoder transformer from our original paper on steroids that does one by one completion of the beginning text. Right? If you ever chatted with ChatGPT, you see how it does it word by word. Right? It's not done for the dramatic effect. It's done just because it's literally word by word, token by token, generate the completion of the text that you fed it. Right? So these transformers, decoder and encoder, started to live their own independent life. Right? If we look at the evolutionary tree of large language models, you would see that up to 2021, most of the effort was on the BERT and their derivatives that are doing extracted semantic meaning from the text. It's great for things like sentiment analysis, for comparing semantic similarity. This is the time that we in Redis saw the future in this technology, and we implemented vector similarity search, basically comparing these embedding vectors at scale and identifying most similar vectors. And then in last year, ChatGPT happened. Everybody all of a sudden understood that, hey, this technology, this decoder-only completion engine, has the power to change the world, right? And here we see all the decoder encoder-only model, BERT, and all the derivatives, and the decoder-only is all the generative AI as we know it. Right? So we're going to talk about vectors and vector embeddings. Essentially, the engine generating the vector embedding is kind of a smaller, lightweight cousin of the generative AI models that we use today. Right? Encoder has just hundreds of millions of parameters. It's relatively small, like size of encoder is maybe hundreds of megabytes, maybe single digits gigabytes, where decoder architecture like ChatGPT, they are huge. They require specialized hardware and so on and so forth. So really big difference, but they come from the same root, from the same original paper. Attention is all you need. Now, what brings them together today? Again, you probably heard retrieval augmented generation, grounded LLM, avoiding hallucinations many times today, and you'll be hearing about that over and over again because that's the hottest topic in today natural language processing. To position retrieval augmented generation, it's kind of in between your traditional search. Think of Google or Bing or your SharePoint, and the pure memory-based things like ChatGPT, Google Palm, Facebook Llama, and so on. Right? It's useful to do a whole bunch of things. Probably the biggest absolute necessity for retrieval augmented generation is there's just so much you can feed into the prompt window, token window of large language models. So you can't feed all your internal data into ChatGPT and say, hey, answer me the question. You need to pre-select the data that's relevant to your question. Right? Avoiding hallucinations, giving you observability and traceability of what happened with your system, like a whole bunch of positive sites. Again, there are a lot of talks about retrieval augmented generation. But if you think about high-level architecture of retrieval augmented generation, retrieval augmented LLM, you need three components. You need embedding generation, think of BERT and derivatives. You need vector database, and you need large language model. Okay? If you'll put it all together and really deploy that to production, that's one of the examples of how you would do that. You take all your documents, you put them in a blob storage, you split it into chunk, load into vector database in the form of embeddings, and then your user asks the question, right? You run it through the same embedding engine, you find the most similar chunk of text from your internal body of text, and you feed it into the large language model. In this case, we're talking about Azure OpenAI. Right, we at Redis obviously use Redis as vector database, but you're not limited by Redis only. And this is the, so to speak, POC in the box that you can run. Just drop your files, PDF documents in the folder, run Terraform apply. You would have entire infrastructure totally private to your organization. Right. If you do the same thing on Google Cloud, right, you would use Vertex AI Palm model as your large language model. You might use Gecko engine from Google to build your embeddings, or you might use something like embeddings from Hugging Face. right? There is no dependency between embeddings and large language model. If you'll put that all together, again, you have three components here: embeddings, vector database, and large language model. We're not focusing on large language model, we're focusing on the two other things today. Right, embeddings. You can choose embeddings that are out there. Hugging Face is a great source of embeddings you can run on your own hardware, on your own notebook, but you can use embeddings from the vendor of large language models, such as Ada from ChatGPT or Gecko from Google. In terms of what you use for your vector database solution, again, there are multiple choices there. There are libraries. FAIS is a great example. F here stands for Facebook, another great contribution of Facebook or Meta into natural language processing world, right? But it's a library. It's not really a database that you would put a production load on. There are purpose-built vector databases such as Pinecone, and there are traditional database vendors such as Redis that put vector database similarity into the existing database. Right? So let's talk about how do you choose the components. There was a great talk earlier today, right, explaining what vectors is. I'm using the same example. Right? Vector is like multi-dimensional set of numbers. If you take vector for representing king, subtract vector of the man, add vector for a woman, you most likely get a vector for a queen. Right? I would not go into details of that, but like pretty much all the vector embeddings model allow you to digitize semantic meaning of the text into set of numbers, right? And that's what embeddings do. And there are a whole bunch of other things that you can do with vector embeddings and vector databases, not necessarily requiring generative large language model. For instance, one of the early adopters of Redis Vector Similarity Search, company from Australia, Relevance AI, they used embeddings and Redis as a vector database to identify cheaters in online multiplayer game. I have no idea how exactly, but somehow they turn into vector the gameplay of particular player, right? And they looking for outliers. So whatever they do, they solve the problem of identifying cheaters in multiplayer game using vector engine. But there are other applications for vector databases totally outside of generative AI as we know it today. So, how do you choose embeddings and vector database? Again, embedding doesn't have to be from the same vendor as the vendor of your large language model. If you use an OpenAI as your large language model, you don't have to use Ada as your embeddings. Actually, if you look at the Hugging Face is a great source of embeddings that you can run on your laptop, or on your cloud instance, or in your notebook. Right? They maintain the benchmark of those embeddings. Right? And OpenAI Ada is just number 10. It's not number 1. It's aware of a lot of languages. Embeddings are really high quality, but based on this benchmark, it's not necessarily the best embedding out there. So look at the cost, look at the performance, right? If you use an OpenAI embedding, the only way you can use it is to send requests somewhere out there to the OpenAI servers and retrieve that. Why don't you use that right within your own runtime? Right? Cost is actually the very big factor there. Right? If you look at the OpenAI price list, like you would see that cost of embedding per token is 20 times less than cost of generating the data using large language model. Now, you might think, oh yeah, that's peanuts. I would not worry about it. You should. Because if you essentially looking for a needle in a haystack, you need to build embeddings for entire haystack, and in your development cycle, you'll be doing it over and over and over again because like, okay, what is the chunk size, like how they overlap and so on. All right, so my personal experience working on one of the projects that been on the previous slide, 70% of my OpenAI build was for embeddings, not for large language model, not for generation. Right? And embeddings, unlike generative large language model, are really easy, really lightweight, so you can use them in your own solution. If you're using high-level frameworks such as LangChain, like it's 2 lines of code to enable OpenAI embedding, 2 lines of code to enable Hugging Face embedding. Right, so seriously consider bring your own embeddings if you build in Retrieval Augmented Generation project. Right, vector database. Right. On the right, you see the math behind the vector similarity. Cosine similarity, my kids are in a high school, they can probably figure it out on their own. Right. It's simple, it's hard to do wrong. If you're doing that in scale, you need to build secondary indices, but again, the algorithms for that are well known, well publicized. If you have 2 vector databases that give you substantially different results for the same queries on the same algorithm, one of them, at least one of them, should not be in software business. Okay? Right. So if you think about vector database, think about vector and database. Vector is math. It's simple, it's well known, like everybody should be able to do that. Database part, scalability, high availability, especially security, if we're talking about enterprise cloud, this is the hard part. Right? We have a lot of customers, traditional enterprise customers that use in Redis, like for their cache and session store needs. They talking to us not necessarily because they see Redis as the best vector database ever. They see us because we are vendor that pass all the security clearance, has all the certification they need, and that's already approval vendor, right? For like big bank, it might take up to a year to get master service agreement, vendor agreement, all the security clearance, and so on. Right? So think of the database part of the vector database, right? And here, this is just a list of all the security credentials and certificates that Redis has as a database. But again, if you choose between pure play vector databases that have to catch up on the database part, especially this enterprise part, such as security, scalability, and compliance, right, and traditional databases that aid in vector similarity, my bet, regardless of the fact that I work for Redis, would be on traditional database vendors, at least at this moment of time. Right. So how else can you use database such as Redis in large language models, right? First one is a context retrieval, is vector database in the Retrieval Augmented Generation model, right? Another one is LLM cache. My colleague Tyler Hutcherson would be doing tomorrow talk about using Redis as a semantic cache for large language model, right? So that's traditional business for Redis, what we've been doing for a lot of years. Now we're adding the semantic layer to this cache. And LLM memory. If you ever talk to ChatGPT, to OpenAI, like it kind of remembers the context of all your previous conversations and context of your conversation. The ChatGPT itself, the model, does not. Like it's a database that sits on the side that remembers it. And actually, ChatGPT already using Redis just for that. It's kind of weird to bring the outage as a bragging point for the database vendor, but what actually happened in March 2023, ChatGPT had a worldwide outage. And the nature of the outage was like customer would start seeing under some weird circumstances conversations by other customers, right? We are a vendor of Redis. They contacted us, quickly identified that it's a problem in the client-side code connecting to Redis. Right, but we know that, we help them to fix that, we get the best endorsement the database vendor can get from a company like OpenAI. Right, they would continue to use Redis for that purpose and hopefully for many other use cases. So if I can quickly summarize like what we talked about today. So vector embedding, like something that generates embedding, and the generative AI as we know it today, they came from the same paper. Attention is all you need. You can think of embeddings as a smaller, younger cousin of generative LLM, right? If you build in Retrieval Augmented Generation or Retrieval Augmented LLM, the term you might hear is grounded, LLM grounded generation, you need embeddings, vector database, and large language model. You can choose 3 of them independently. You don't have to rely on embeddings from the LLM provider, right? And pick your embeddings wisely. Embeddings is something that you can totally run on your own. I would think twice before provisioning infrastructure for running something like Llama 2, but for embeddings, it's no-brainer. You can do that, and you would save a lot of money if you do that, especially in the development cycle. Right? And then you choose in a vector database. Vectors are easy, databases are hard. So look closely at the database part of the vector database. That's it. I don't know if we have any time for questions. There are a couple of links for you. Redis Ventures GitHub is a great collection of resources that you can use, like all the solutions that I showed you with Azure, with Google AI are on that GitHub. You can run Redis stack locally, even right within your own notebook, or you can provision free version of Redis in the cloud with Vector Similarity Search, and so on. And on that, thank you very much. And if we have any time for questions, I don't think we do, but